Okay, good morning sa inyo.
Morning po.
Okay, so let's discuss yung last topic natin for this semester, yung high frequency response of transistors ng BJT tsaka ng FET. So okay. So sa high frequency response, okay, sa matataas na frequency, so yung amplifier natin, the BJT and FET amplifiers, yung gain nila is naapektuhan nung mga capacitances. Okay? Ano yung mga capacitances nito? Kung sa low frequencies, ang nakaka-apekto lang sa gain is yung mga bypass capacitor and the coupling capacitors ng amplifiers natin. Dito, maraming kinoconsider na capacitances kapag we're talking about high frequency na. Okay? So dito sa BJT, so makita nyo yung amplifier BJT natin, so meron tayong tinatawag na so we have yung junction capacitance. So yung junction capacitance, so yun yung mga capacitance na nabubuo between the junctions ng ating mga amplifier. For BGT, we have yung CBC, ayan. We have CBC. Then for CCE and CBE. So yun yung apekto sa BGT natin. Samantala, sa ating FET amplifier, so ang mga capacitances na nakaka-apekto ay yung CGD, CDS, and CGS. Okay, so besides sa mga junction capacitance, so nakaka-apekto rin sa gain at high frequency yung tinatawag nating wiring capacitance. So yung wiring capacitance, okay, yun yung capacitance na nabubuo pag between sa mga kinakabit natin na wiring or yung mismong terminal, okay, yung tawag dito, yung mismong mga paa ng ating ng component, di ba? Yung BGT tsaka PET, di ba, mga paa yan. Okay? So, yung mga wiring na ginagamit doon is nakadagdag ng capacitance kapag mataas yung frequency. So, yung mga yon, so we have here yung CWI or yung capacitance na nabubuo sa wiring sa input, then CWO, yung capacitance na nabubuo ng wiring sa output. So, ganoon din sa FET with CWI and CWO. Okay? Then lastly, yung capacitance na nakaka-apekto sa gain at high frequency is yung tinatawag nating Miller capacitance. Miller capacitance. Ano ba yung Miller capacitance? Yung Miller capacitance is yung capacitance na na-perform or nabubuo sa isang PN junction. In BJT's case, yung Miller capacitance is nabubuo doon sa base collector junction, while sa FET, yung Miller capacitance is nag-perform sa may gain drain junction. Okay? So Miller capacitance, so ulitin ko lang, the Miller capacitance is the capacitance formed or that develops on PN junctions. In BJT's case, so we have yung base collector junction, and for the FET, we have the gate drain junction. Okay? So sa high frequency, high cutoff frequency, so meron tayong dalawang kino-consider lang. We have the input network and output network. Unlike sa ating low cutoff frequency, so tatlo yung kino-consider natin doon. So we have yung sa may every terminal, kino-consider natin yung low cutoff frequency doon. But for higher frequencies, so we are considering only two. We have the input and the output networks. So ito yung mga formulas CI, where RTHI is equal to RS, parallel with RB, parallel with the ZI or the input impedance. And CI is the total input capacitance, which is the summation of the wiring capacitance at the input, the capacitance at the BE junction, and the Miller capacitance at the input. So yung Miller capacitance input is equal to 1 minus AB or the voltage gain multiplied by CBC. CBC is yung junction capacitance at the base collector junction. Yeah. Then for output network FHO for BGT, so we have 2 pi, 1 over 2 pi RTHO CO, where RTHO is equal to the input impedance parallel with the load resistance. And yung CO or the total output capacitance is equal to the summation ng output wiring capacitance plus the CCE or the capacitance at the CE junction plus the output Miller capacitance, which is equal to 1 minus 1 over AB or the gain multiplied by CBC. Then for our FET amplifier, yung high frequency at the input network is 1 over RTHI-CI. So ito yun lang general formula niya, wherein yung RTHI mo is equal to RSig or yung resistance sa may voltage signal natin parallel with our input impedance. And yung ating CI or the total input capacitance for FET amplifier is equal to yung wiring capacitance at the input plus CGS or the junction capacitance between the gate and the source plus the Miller capacitance at the input, which is equal to 1 minus AB or the voltage gain multiplied by CGD or the junction capacitance at gate drain junction. And for output network naman, FHO or the higher cutoff frequency at the output network of a FET amplifier is equal to 1 over 2 pi RTHO CO, wherein yung RTHO is equal to ZO or the output impedance parallel with the RL or the road resistance. And yung CO natin is equal to wiring output capacitance plus CDS or the drain source capacitance plus CMO or the output pillar capacitance, which is equal to 1 minus 1 over AB CGD. So yung lima formula tatandaan nyo dito. Yeah. So let's try solving some examples using that formula for higher cutoff frequencies. Let's first for BGT. So hindi ko nididrawing yung circuit. Binigay na lang dito yung mga values ng parameters. We have RS 1K ohms, RL 2.2 kilo ohms, BET is 100, R1 is 40 kilo ohms, R2 is 10 kilo ohms, RE is 2 kilo ohms, RC is 4 kilo ohms, VCC is 20 volts, CBE or the junction capacitance at base emitter network is 36 picofarad, CBC is 4 picofarad, CCE 1 picofarad, CWI at 6 picofarad, CWO 8 picofarad, CB 10 microfarad, CC 1 microfarad, and CE 20 microfarad. Okay. So let's determine first yung FHI or high cutoff frequency at the input network. So 1 over 2 pi RTHICI. So let's first find yung RTHI. which is equal to, according to the formula, RTHI is equal to RS parallel with RB parallel with ZN. So RS parallel with RB. Okay, so let's see. So, ano yung uh, input impedance ng ating amplifier? Considering isa siyang common source amplifier. Ano yung input impedance for common source? Ha? Edit ko lang yung formula dito sa ano. Sobra dito. That is ZI. Yan, ZI. Yan. Ano yung input impedance for common source? ZI is equal to ano? Common source input impedance. Ano yung formula doon? Ano yung formula?
RG.
RG? Nagkaroon ng RG. BJT tayo BJT amplifier, common source. Ay, common source, sorry. Common emitter. Kaya pala. Common emitter BJT.
RB parallel beta RE total po.
Ayan. So, we have RB parallel with beta RE total. Yung doble yung RB dito. Sa Z-in, meron na palang RB doon. So, wherein yung RE total natin can be computed as ano, yung resistance sa may emitter plus yung AC dynamic resistance, RE. So, since we're talking about common source, then makita nyo naman, meron tayong CE or may bypass capacitor sa ating emitter. Okay? So, pag tinumpit natin yung RE total, so, mababypass si RE. Okay? So, yung RE total natin is just simply yung RE. Wherein yung RE na yan is equal to sige, mawala. $26 MB over IE. So how will we determine yung RE? So yung RE, sorry para mas ma-visualize natin si IE, makita natin. So, i-construct natin yung amplifier. Okay, may R1, may R2, so 20 volts VCC, RC is 4K, RE is 2K, R1 is 40K, and R2 is 10K. So, ayan. So, we have voltage divider configuration. So, hanapin natin si IE. So, how can you determine IE? So, of course, gawa tayo loop. So, umpisa tayo sa base emitter loop. So, since voltage divider tayo, so gamitin natin yung exact na lang. So, hanapin mo natin si ETH. Yung ETH natin will be 20 volts multiplied by 10K over 40K plus 10K. So, ilan si ETH?
4 volts.
4 volts. In RTH will be 40K parallel with 10 kilo ohms. So, ilan si RTH?
8 kilo po.
Eight k po, sir.
So, ito. Let's continue. Ilan si RTH dito?
8k.
8K po.
We have 8 kilo ohms. So, pag ayusin natin to, yung circuit natin will be sa mga ganito siya. So, ito si 4 volts and 8 kilo ohms to. So, we can now form yung loop sa ating base emitter. So, we have 4 volts minus 8 kilo ohms IB minus 0.7 minus 2K IE is equal to 0. Then 4 volts minus 8K IB minus 0.7 minus 8 kilo ohms. Yung relationship between IE and IB, so we have beta plus 1 IB is equal to 0. Therefore, we can now determine IB. So, IB is 4 volts minus 0.7 volts all over 8K plus 100 plus 1 times 2K. So, ilan si IB? IB is equal to
15.71 micro.
Therefore, our IA is equal to 100 plus 1 times 15.71 microamperes. That is equal to, ilan yan? Ilan to?
1.59 milli po.
So, 1.59 milliamperes. So, therefore, we have 26 millivolts plus over 1.59 milliamperes, or RE is equal to ilan?
16.35 po.
Okay, so therefore, we can now determine our input impedance is equal to RB. Okay, our RB is also equal to RTH, so 8 kilo ohms, parallel with beta, which is 100, times RE total, which is only equal to RE, 16.35 ohms. So, ilan yung ating Zn? Ilan?
1,357.55.
1,000.
357.55.
So, 1.36 na lang. Okay, 1.36K. So, after that, we can now determine RTHI. RTHI is equal to RS parallel with Zn, which is RTHI is equal to RS. Ang RS natin dito ay 1 kilo ohm parallel with 1.36. So, ilan si RTHI? Ayan.
$576.27.
Okay? So, next tayo, yung total input capacitance which equal to CWI plus input is CWI, CBE plus input Miller capacitance CBE plus CMI. So, according sa given natin, our CWI is 6 picofarads. So, CI is equal to 6 picofarad plus ang CBE natin ay 1 minus AB multiplied by sa base collector, CBC, that is 4 picofarads. So, yan. So, kulang pa tayo ng AB, which is voltage gain. So, our voltage gain is, negative.
Negative RC over RE total.
RE total. Okay? So, ang RC natin is, given na? RC, 4K, 4 kilo ohms. So, negative 4K over RE total, that is 16.35. So, ilan yung ating voltage gain? Ilan? 4K?
Negative 244.
Ilan? Negative? Ilan? Negative ilan? Ilan?
Negative 244.65 po.
65. Okay, so our total input capacitance will be 6 picofarad plus 4 picofarads plus 1 minus, so plus na yan, 44.65 kasi minus 4 picofarad. So, ilan input capacitance natin?
Sir, 4 picofarad po ba talaga katabi ng 6 pico? 36 po kasi yung...
36. Sorry. Yan, mali akong sulat. 36. Okay. So, ilan na siya? CI. Ilan? Ilan na?
1.02 nano farad po. Yung akin.
How about sa iba?
Ganun din po.
Okay, so yan. Kung pareho kayo, mukhang tama naman yan. So check natin. So tingnan natin yung magiging higher cutoff frequency natin at the input network. So FHI is equal to 1 over 2 pi times 576.27 ohms times 1.02 nanofarad. So ilan si FHI?
Two 270.77 kilo. Hertz.
Okay, so saglit lang, check ko lang ha. Okay, so yan. So ilan yung nakuha niyo sagot?
7 kilo.
Hertz. Okay, so okay na tayo doon sa input network. So output network naman. So 1 over 2 pi RTHO CO, where RTHO is equal to RL parallel with the output impedance. So RL natin is 2.2 parallel with ang output impedance natin for common source is RC, which is 4 kilo ohms. So ilan si RTH? So ilan siya?
$1.42 na kilo.
So ilan ulit? 1 point.
$1.42 kilo.
Okay. So CO, RCO is CWO plus uh, CWO. So we have C. Saan na yan? CCE. Yeah, CCE. CWO, CCE plus CMO, wherein yung CMO natin is 1 minus 1 over AB multiplied by C, B, C. So let's compute for output capacitance. CWO is given dito. CWO 8 picofarads. CCE is 1 picofarad. CCE is 1 picofarad plus 1 minus 1 over negative 244.65 CBC. Our CBC is 4 picofarad. So, ilan yung ating CO? Ilan? Ilan siya?
$13.02 pico po.
So, ilan ngayon yung ating higher cutoff frequency at output network? FHO. So, 1 over 2 pi times 1.42K multiplied by 13.02 picofarad. FHO is equal to ilan?
8.54 mega po, sir.
8.54
Mega po.
So, ayan, 8.54 megahertz. Okay, so FH natin is 200, 270.77. Yeah. So, alin dito yung high frequency response natin? Kung sa lower frequency response, kung sa lower frequency response, ang kinoconsider natin nun is yung pinakamataas among the lower cutoff frequencies. Dito sa high frequency response, we're considering yung mas mababa sa dalawang cutoff frequency. Which means, yung frequency response, high frequency response natin is at the input network, yung mas mababa is 270.77 kilohertz. Okay? So, kung i-graph natin yan, so graph ulit natin sa bold plot. So, ito 10, 100, 1,000, 10,000, 10,000, tsaka 5. $100,000. So, 6, 1 million. Then, 7, so that is 10 million. So, we have 3, 6, 9, 12, 15, 18, 21. Okay. So, first, plot muna natin yung mas malaki. Okay, 8.54. So, take the logarithm of 8.54 megahertz. 8.54 megahertz. So, ilan yan? 8.54 million. So, ilan yung logarithm niya?
$6.93 po, sir.
So, dito siya. So, malapit sa 7. Okay. Then after that, Sa lower cut of frequency na ginagawa natin, kinukuha natin yung logarithm ng first octave, di ba? Backwards. So ito forward naman. Ilan yan? Ilan? 2 times 8.54 mega times logarithm of 2 times 8.54 mega.
7.23 po.
So, i-plot natin siya sa negative 6 dB. So, malamang dito siya. Tatansyahin ko na lang 7. So, malamang dito. Then last logarithm of yung first decade, 10. 8.54 megahertz. So, ipa-plot natin yan sa negative 20 dB. Sabitan ko nga. Ayan. So, ilan? Nasa may 8 or 9? Ilan to? 8 siguro?
7.93 po, sir.
So, kung ito yung 8, so malamang dito siya. So, ayan. Okay. So, next tayo. Burahin ko naman yan. So, computein natin yung 270. So, logarithm ng 270.77 kilohertz. So, ilan to? Dito yan sa gitna ng 5 tsaka 6. 5 point something.
5.43 po.
So, malamang dito siya. Yan. Ay, dito. So, first octave. Forward. So, ilan yan? Then, lastly, yung decade. Yan. So, ilan tong pangalawang point? Nasaan dito? 5 point something.
5.73.
So, 73. So, dito siya. Malamang. Yan. Tansyahan lang. Then, lastly, yung 10 times 270.77.
6.43 po.
So, dito siya. Yeah. Yeah. So, that's how. Then, let's plot yung negative 3 dB point. So, negative 3 dB point. Yan. So, kung ito yung negative 3 dB, so gawin mo na asymptotic yung line na yan. Yan. So, that's yung high frequency. For example, yung nakaraan natin, di ba? Kung sa part na to, yan. Yan. So, kung ito yung graph sa low frequency, so ito yung cutoff. Therefore, hindi. Tingnan ko lang para yung nakaraan natin, hanapin ko lang kung saan natin i-graph. So, yan. Nakalagay siya dun sa ano, 238, 2.08, 1.38. Graph ko lang ha. So, balik tayo. Yan. So, graph ko lang. So, yung low frequency response natin sa example, kasi pareho lang naman silang yung parameters. So, that is FLS is equal to 238.73 Hertz. Then, yung graphs niya sa 2.38, 2.08, and 1.38. 1.38. So, dito siya. So, ayan. Okay. So, hindi lang masyadong maganda. So, ayan. Ayusin ko lang ah. So, 2.38, 2.08, 1.38. So, malamang ito siya. Then, plot natin sa negative 3 dB point. So, yan. So, ito yung pinaka-itsura ng frequency response natin. Then, ito yung bandwidth. So, gaano kalaki yung bandwidth na to? Yung bandwidth na to, yung, yung bandwidth is equal to yung high frequency response minus the low frequency response. So, ang frequency response natin dito sa high frequency is 270.77 kilohertz minus yung sa low frequency naman, that is 238.73 hertz. So, ilan yung bandwidth natin? So, paki-compute. Ilan? Ilan ngayon yan? 200 something. Ilan? Ilan? Ilan na?
270.53 kilo po sa akin, sir.
Okay. Yeah. So, given naman yung formula, gayahin nyo lang ginawa natin sa may BJT. Ibigyan ko kayo ng last assignment nyo. Ito. Pakigawa to. Paki-screenshot nyo na. Yan, ito. Pa-screenshot. And pakipass sa akin, ano ba? Sa Saturday, Sunday, Monday. Date is, ano ba sa Monday? May 30? Okay, sa katapusan, May 31. Hanapin nyo. So, kailangan i-plot nyo yung high frequency response on the both plot. Okay, so ayan. Screenshot. So, deadline natin for submission is May 31, 2022. So, gagawa na lang ako ng submission sa Canvas para doon yung siya i-upload. Okay, na-screenshot yun na. FET to FET. So, yung kanina, so yung formula ng FET is, ito siya. Saan na?
FET na common source po.
Yes, common source FET. Yan. Ito sa input tsaka output networks. Okay. So, may question pa ba? So, that ends our lesson for this second semester. So, mag-review kayo next week for exams and quizzes. Okay. May question pa? Tanong pa kayo? Ay, may tanong pa kayo. Meron, wala.
Wala na po.
Okay, sige. Open na tayo ng camera. Okay, check ko lang yung walang camera ya. Kung andyan talaga kayo. John Mark,
Dito po.
Elise,
Present po.
Eric, Lucas. Eric? Wala.
Po? Ako po ba, sir?
Oo.
Sorry po, sir. Medyo maingay po
John
dito.
Mark. Santos.
Present po.
Jonas.
Present po, sir.
Jose. Pulang Bayan.
Sir.
Jim.
Present po.
Jerian. Jerian. Wala. Wala. Iram.
Present po, sir.
Saglit lang.
Sir, Miranda po po.
Sige, okay na. Okay na tayo. So, sige. Goodbye, class.
Bye, sir. Thank you po.
Thank you po, sir.